Okay, now let's review torsional shear stress. And we have here a segment of shaft or bar. It is under the application of a pair of torque. All right, so in each cross section, we should see the same shear stress distribution. Again, the diameter of this shaft is d or phi. All right, so I did a cut and flipped it over, and then I have something like this. The shear stress distribution, for this case, it has to be as what I'm showing over here. So that basically all the stresses are in these cross section, not on the surface. Okay, even at the surface, the stress is in the surface. Okay, so the surface is free of any stress. Okay, and then the summation of the stress would end up with 0 force, because in the cross section we only have torque, we don't have force. And then integration of the little torques produced by this shear stress would end up with the torque value. All right, and we can use C to show the distance from the center of the shaft to any location. And then the torsional shear stress gives us such an expression, which basically is the shear stress, okay, equals torque by this distance C, and then divide by J. J is this polar second moment of area, which is pi d power 4 and 32. Okay, so that ends up with this value. So again, maximum is on the surface when C equals the radius, okay, 1/2 of d. And then we get to the surface stress, and this is the maximum torsional shear stress. All right, so we know that on surface, they are basically the same thing, so that's why I marked a number of red dots. We can pick up any of these, and I pick up the middle one, and I show that the stress state on top of this. All right, and you can definitely see that the tau xy and tau xy corresponding to that coordinate system. All right, but no matter what, all these points, all these surface points shares the same shear stress value, but because their location may be different from that coordinate system, but the one that I pick up in the middle goes with the coordinate system. All right, so that's why sometimes we use tau xy, but sometimes we just don't. We just use tau shear stress. Okay, that's for this short movie.